Aging isn't just about wrinkles or gray hair. At its core, it's a gradual unraveling of cellular energy, repair systems, and resilience. And deep within that biological wear and tear lies one molecule that plays a startlingly central role: NAD, short for nicotinamide adenine dinucleotide. This molecule, derived directly from niacin, vitamin B3, is the fuel for many of the body's most vital cellular functions. Without enough NAD, cells become tired, inefficient, and vulnerable to damage. And as science increasingly reveals, the decline of NAD may be one of the silent drivers of aging itself. Niacin is the dietary key to this process. It's the building block for NAD and NADP, which are coenzymes involved in hundreds of reactions throughout the body. From the way your mitochondria produce energy to how your cells repair DNA damage, respond to stress, and regulate inflammation, niacin via NAD is quietly keeping the whole system from falling apart. In youth, NAD levels are abundant. Cells are energized, mitochondria are humming, and repair mechanisms are quick and efficient. But starting as early as our 30s, NAD begins to decline. By middle age, levels can drop significantly, and by old age, they're often a fraction of what they once were. This decline corresponds with many of the classic signs of aging: reduced energy, cognitive fog, increased fat accumulation, muscle weakness, inflammation, and a greater risk of chronic diseases like diabetes, heart disease, and neurodegeneration. Why does NAD decline? Part of it is just the wear and tear of life. The enzymes that consume NAD, like PARPs, involved in DNA repair, and CD38, involved in immune regulation, become more active under stress, inflammation, and oxidative damage. The more damage your body is fighting, the faster your NAD supply gets drained. At the same time, your ability to synthesize NAD from niacin or tryptophan diminishes with age. It's a double hit: increased demand and reduced supply. This is where niacin comes into play as a powerful nutritional ally. By providing the raw material to rebuild NAD, niacin can help restore metabolic function and slow the cellular aging process. It doesn't stop time, but it may help cells function more like they did when they were younger, more energetic, more resilient, and better at bouncing back from stress. Mitochondria, often called the powerhouses of the cell, are especially dependent on NAD. These organelles convert food into usable energy, and they suffer dramatically when NAD is low. With declining mitochondrial function, energy production stalls, cells accumulate waste, and tissues begin to degenerate. This is seen not just in obvious areas like muscle or brain, but also in organs like the liver, heart, and pancreas. Boosting niacin intake has been shown to elevate NAD levels, which in turn supports mitochondrial biogenesis, the creation of new mitochondria, and enhances mitochondrial efficiency. Animal studies have found that NAD restoration can improve endurance, reduce signs of cognitive decline, and even extend lifespan in some cases. In humans, the picture is still emerging, but early trials with NAD precursors like nicotinamide riboside, a more targeted form of B3, have shown improvements in markers of metabolic health, inflammation, and muscle function. There's also growing interest in niacin's role in activating sirtuins, a family of proteins nicknamed longevity genes. Sirtuins rely on NAD to function and are involved in regulating metabolism, DNA repair, circadian rhythm, and stress resistance. In a way, niacin acts as the on switch for these cellular guardians. When NAD is abundant, sirtuins can perform their duties efficiently, helping clean up damaged DNA, reduce oxidative stress, and preserve the stability of the genome. But when NAD runs low, those systems start to falter, and aging speeds up. Beyond just energy, niacin supports aging defenses on multiple fronts. It helps regulate inflammation by modulating immune cell activity, supports the integrity of blood vessels, and contributes to healthy lipid profiles. Its role in DNA repair is crucial for maintaining genomic stability, reducing the risk of mutations that can lead to cancer or cellular dysfunction. And by supporting NADP-dependent antioxidant systems, it helps buffer against the daily oxidative damage that accumulates over time. None of this means that niacin is a miracle anti-aging pill. Aging is complex and influenced by far more than one vitamin. But it does mean that ensuring adequate intake of niacin through food or supplements can help support the core cellular machinery that keeps aging in check. It can mean more days with energy, sharper cognition, better metabolism, and a slower march toward degenerative decline. Foods naturally rich in niacin include turkey, chicken, tuna, salmon, peanuts, mushrooms, and fortified grains. For most people, a balanced diet provides enough to prevent deficiency, but older adults, especially those with chronic illness or poor absorption, may benefit from increased intake, either through food variety or low-dose supplementation. More targeted NAD-boosting compounds like nicotinamide riboside and nicotinamide mononucleotide, NR and NMN, are being studied for their potential in supporting healthy aging, though they come at a higher cost and with less long-term data than standard niacin. In the end, vitamin B3's connection to aging is one of restoration, restoring energy, restoring repair mechanisms, and restoring balance to systems that slowly lose their rhythm with time. It may not reverse the years, but niacin can help make them stronger, steadier, and a little more resilient. In the conversation about aging gracefully and staying vital, this quiet nutrient deserves a much louder voice.